Okay. This is a typical limiting reagent or reactant problem. We have two, what are the givens here?
23.2 grams of ethane.
Ethane and oxygen. It's two givens. Whenever you see two givens, we've got to do the same process we went through with the bicycles. We've got to figure out which one makes the least amount of product if the other one was in excess. Okay, so step number one is the reaction. Is the reaction balanced? No, it's not. Okay, so we're going to do CHO. Now, we can work with liters, we can work with number of particles, we can work with grams. This problem is going to be a gram problem. Because there's some more additional conversions you have to do if it's not in grams. We're just going to stick to grams. This is going to be challenging enough. Okay. So we've got 2 carbons on the left, 2 carbons on the right. 8 hydrogens on the left, 8 hydrogens on the right. Oxygens. How many oxygens do we have? Well, we've got 4 and 4 is 8. Right?
Oh, you're balancing it as you go, right?
I am.
Oh, okay.
Yes. Just.
And
then we need 8 oxygens on the left. Okay, so it's balanced now. Now, balancing the equation is crucial because that's the middle step of our calculation. Okay, so we're looking at water production. Now, down at the bottom, it says the actual yield is 5.67 grams. Life is like this. You never get 100% yield. There's too many steps involved or you can waste product. Okay, so this one only produced 5.67 grams. Now the actual can never, no exceptions, never be more than the theoretical yield. Theoretical yield is what you yield on paper if everything goes perfectly. I can guarantee you, my first job out of graduate school was I worked at Spreckels Sugar. And my job was to maximize product. Product was white granulated sugar. Every place there was a leak, we're losing sugar water. So we went through and maximized product by fixing the leaks, maximizing crystallization, a bunch of stuff like that. But we never got the theoretical yield. We approached it. And that's what usually chemical engineers' main job is. 9 times out of 10, that's what you do as a chemical engineer, is you look at product efficiency. Okay, so what we do is we're going to start with, we just choose either given, it doesn't matter which one. It's going to be frames or wheels. All right, so let's choose ethane. So that means the given is 23.2 grams. And then we need to convert it to moles. So that's okay, so we've got 2 carbons at 1201 apiece. So that's 8 hydrogens at 101. Okay, so that's
it's not 18.02 grams for 1 mole.
Huh?
You're the 18.02 grams for 1 mole. You're
Yeah.
adding, you're getting that from the
Yeah.
periodic.
Okay, so that's the molar mass of ethane. Okay, so grams needs to cancel, so gonna be in the bottom. And this is the ethane. Okay, now that's step number one. Convert the given to moles. No exceptions. Always convert to moles. Now we can use the valence equation coefficients to get over to water. The water needs to be on top, ethane on the bottom. Okay, water is 4, ethane is 1, water. Okay, this will give us, if we only were working with ethane, how much water would be produced?
This is your base.
Okay, so that's step number one. Then we're going to do the same thing with the other given. And then we're going to compare the two amounts. Okay, so we're going to do the same thing with the 34 now.
Made everything backwards. Sorry.
Okay, so we're going to compare now 52 to 19. So which is limiting the product, oxygen or ethane? Which number is smaller? Oxygen. So that's the one limiting the reaction. Okay, it says how much of the non-limiting reactant remains. Now we have to figure out how much ethane we actually use. So we're going to start with the limiting reagent, which is oxygen. And the product now is going to be the ethane. And that'll be how much we actually used of the ethane. When we started with 52 grams, we're going to have excess left over. And so that's the next calculation. So this series of calculations determines the limiting reactants. You have to do both of them. And you can't eyeball it either. Okay, so we're gonna start with the limiting reactant, which is the oxygen. And the product now is going to be how much ethane is produced. So we're going to start with 34.5. Oxygen needs to be in the bottom. Ethane needs to be on top. And the molar mass for ethane is 3210. So this is going to be okay. So we used of the 56, excuse me, of the 23 grams, we used 8.65 grams. How much is left over? That's a subtraction problem. So we started with 23.2. So our initial mass was 23.2. We used 865. So the excess is going to be subtraction. So we had a little over 14 grams in excess. Now, the problem states that we made 5.67 grams of water. Our theoretical yield of water is 19.4. So to get percent yield, I'm going to take the 5 67 divided by the theoretical times 100. So this is okay, so that's okay. So this is what your take-home problem is going to look like. You have to start off, if you have two givens, you have to do two calculations to determine the smallest yield. And the third calculation, you need to find out how much of the excess given you have left over. Then the fourth calculation is you need to determine how much you have left over. And then if it asks for percent yield, that's the fifth calculation. Now, if you mess up the balanced equation, everything is wrong. Because every one of those, except for the last two steps, requires the coefficients from the balanced equation. So, wasn't that fun? Now, this is an example of a more complex problem you're going to run into in this class. In 1A and 2A, you're going to be doing these a fair amount. So
You laugh.
that's why you're taking this. This is why you're taking this class.
When do we get the actual hard problem to take home and work on?
Send me an email, I'll put it up tonight.
Okay, great.
And you have a lot of time to do it.
Okay,
Because the test is until May, so
right.
you have a whole month and a week.
Probably take food. How many questions is on the test?
Hmm?
How many questions is on the test?
The test is kind of a complicated reason that why the test is already done. See, I'm not allowed to use a copier anymore. I'm only allowed to use the print shop. Print shop is a 4-week, you don't get your job back for 4 weeks. So at City, I submit a job in the print shop, I get it the next day. So guess who funded all the tests? Wasn't Sierra. So anyway, I've got all the tests already done. The problem is I need to make sure that the test is consistent with all the topics we've covered. Because see, the topics covered are based on the lab schedule, and I didn't do the lab schedule. So I just have to make sure it's a reasonable test. Okay, are there any questions about this? Now, the good news is every one of these limiting reactant problems is the same. 5 steps. Every single one, pattern. Notice this pattern here. This pattern is the same as this pattern, same as that pattern. 3 parts to every one of those. The middle one is the ratio of the coefficients from the balanced equation. The first part is getting the given to moles. The last part is converting the moles to whatever you're trying to calculate, in this case, grams.
Do another one.
Yeah, let's just, I'm gonna change this problem. So don't start writing down. Okay, so this is a little different problem.
Grams?
Hmm.
Is that 12.8 grams? There's no
Grams, yeah. So the same equation, we're still using, we're burning ethane. So it's gonna be, same equation, only this time we're looking at molecules of water produced, molecules, counting. So what conversion factor are we going to use for that?
Yes.
Huh?
She said Avogadro's number?
Yes, Avogadro's number. That's right. So the last step is going to be, instead of the molar mass, we're going to use Avogadro's number to get the number of molecules. Okay. Now, just real quick, these are being consumed, produce. So whenever you hear something being confused, it's on the left side of the equation. Something is being produced, it's on the right side. Okay, so we're going to basically do the same set of calculations. Okay, so let's do ethane first. So we got 12.8 grams ethane. Now, if you look up the formula for ethane, it's not C2H8, it's actually C2H6. This one, the balancing the equation works out better. So this is kind of a faux ethane. Okay. And we've already done the molar mass for ethane. That's 32.1. Now, in some books and some teachers you take in your next class, sometimes they do this slightly different. Instead of just saying for H2O, they'll go for moles H2O, 1 mole. So it depends on who's teaching the class, what book you're referencing, but ends up being the same thing because the moles cancel anyway. I usually don't put them on there, but it depends on your next class though. I just want to make sure. Oh yeah, I've seen this before, so. Okay, now we do the water and we need grams of water. And water is 1802. Okay. Now, what did I do wrong? Who said Avogadro's number? Oh, okay. Yeah. The middle step? Yeah. Oh, 4 moles water, 1 mole. Yeah. Okay, I shouldn't have used the molar mass of water. I should use Avogadro's number. When I use the molar mass of water, if we're looking at product is in grams, we're looking at how many molecules. So that's going to be okay. Now we're at molecules, not grams. Okay, now we're going to do a similar one using, instead of methane, we're going to be using oxygen. Oxygen is, each oxygen is 16 grams, so 2 of them is going to be 32 grams. And again, to get this from the periodic table, it's a decimal number from the periodic table. Okay, so we need to have oxygen on the bottom, water on top. Okay, so it looks like oxygen is going to be our limiting reactant. It produces less. Okay, so the next step is, so these are going to, this determines the limiting reactant, okay? Which is going to be this guy there. So now we have to determine how much of the ethane we used. So we're going to start with the limiting reactant. And we're going to put the now here we're going to use the molar mass because we want grams here. And that's going to be what is it, 3210. And the reason why we use molar mass is because we want to end up with grams, so we can subtract that from what we started with. If we convert it to molecules, then we have to convert the molecules to grams. So this just cuts out that extra step. There's enough steps here already. Okay, so we started with 12.8 grams. We use 614. Okay, the actual yield is 5.67 times 10 to the 22. So our theoretical oops, excuse me, it's flip-flopped. Okay, so our actual yield was 461.23. Give myself enough room. Okay. So this is a typical limiting reactant problem.
Wait, what was your answer?
12.3%. Make sure you're using the EE key.
Yeah, me too. Getting 81. Oh, was that? So 4.61, that's 20, 5.67.
You got 1.2?
Yeah, 1.22. 1.23.
Yeah, but the 9 gets the second two up to a 3.
Yeah, so 1.23. But you got 12.3.
Yeah, when you multiply by 100 though.
Yeah, so we give her multiplying back. 8.130. I don't know if 8 wants to be pretty fine, so I don't know what my did wrong. I guess I didn't even get that.
Hmm.
I got 8.1305. Okay, that was. Yeah, I don't want to do as well. Yes. I was tempted to.
Yeah. Tell members E22, not 3.
I have 2. 8, that's 10 times 1. The first.
Okay,
See.
I would advise you to go over this 2 or 3 times and do some practice worksheet. You can find those on Canvas files, just do a search on limiting reactant. And you go to you'll go to the page where all this, the simple stoichiometry is there, one we did last week, and then this one, and these will be at the bottom. With answers, of course. And setup and all that stuff. So that's what I wanted to cover today, which is more than enough. Even
Yeah.
though it's only 45 minutes, 50 minutes. Okay, any last minute questions? Saturday, the lab people, um. You can do that dry lab at home if you want, up to you. If you're, if you've never done this before, naming, it's on nomenclature, lab 5. You might want to stick around and make sure you're doing it correctly. But you're more than willing to do it at home. You can also do it out here. I think there's food available too. Might want to peruse what's available.
I'm all good with it.